Okay, so we'll bring up our next speaker. It's Xin Li. He's professor of cold and arid regions Environmental and Engineering Research Institute in Beijing, China. And he's going to take us down the Silk Road, which sounds like a lovely idea. So looking forward to that talk. Thank you.
Okay, so thank you very much. First, I want to thank Howard and John for inviting me to be here. Really great honor for me. And secondly, I want to report to Howard, to John, to Sus and other friends. Currently, I'm moving from the cold and arid region to even cooler but a little bit humid region, the Tibet Plateau. Next one.
Yeah, so that big button.
Oh, this is the next one. So here is the topic of my talk. I want to address water security along the Silk Road. And then the case study, and the third part of my talk is the contribution of Howard Waite to this work. So first, I want to draw your attention to this vast area spans from the west part of China to Europe. From 2,000 years ago, and even 4,000 or 5,000 years ago, we have this road, the so-called Silk Road, across thousands of kilometers to across different cultures, different nations, different environment, and links the cradles of civilization from Mesopotamia to the Indus Valley and to the Yellow River civilization. And currently, this region is getting more attention because there are very high mountains, for example, the Tibet Plateau, the surrounding areas. We call this region the third pole and pan-third pole region. This region is actually very sensitive to the climate warming and also very sensitive to the human activity turbulence. So I also want to draw your attention. There are many inland rivers in this region. From the very east of Silk Road, we have the Shiyang River, Heihe River, Shule River, and then the Tarim River Basin. And the Ara Sea, Aridaya contributed to the Ara Sea. And even to the west, we have the Sistan Basin, we have the Caspian Basin. And this portion of Caspian Basin is the Urmia Basin. We also have the Tigris and Euphrates Basin. If we look into the environment of this region, you can see all this region are hyper-arid, arid, and semi-arid region. Precipitation is just around 15 millimeters to not more than 200 millimeters. But if we look into the human activities in terms of irrigation, we can see overexploitation of water resource almost everywhere in this region. For example, in Tarim, in the Aradaya, in Sirdaya, and also in the West Asian countries, you can see many land are currently used for irrigation, for agriculture. And also this red map just shown by our first speaker this afternoon session. If we overlay these river basins with water security, we can see most of these river basins are in extremely high risk, even mediate to high risk. Because of the over-exploration of water resource and also because of climate warming, we can see in our sea, the lake area shrunk from more than 16,000 square kilometers just 5 decades ago to just 1,000 of square kilometers. And to the west, in the Sistan Basin, we can also see the very significant drying up of these terminal lakes. And here is Lake Urmia. Just a few, 10 years ago, the area is still 6,000 square kilometers, but now it's just, in the year of 2015, just 100 square kilometers. It's got a little bit recovery in last 2 years. And even to the west, we can see very significant range of the Chad Lake in African continent. Behind all this drying up of inland lakes, we can see overuse of shared and unregulated resource. We can call this problem tragedy of the commons problem. Ground challenge of this region is how can we try to achieve the our common future and avoid the tragedy of common on this Silk Road endorheic river basins. We need to develop some win-win approach to ensure economic growth as well as ecological rehabilitation, and further to ensure water security and ecological security to make the sustainable development of the river basin in this area possible. So there is some ground and big challenges in this region. And the second part, I would like to use one of the endorheic river basin in northwest China as case study to introduce some integrated water study to pursue this kind of sustainable development of inland river basins. This river basin is located here. Here is the arid region of China. Here in the Xinjiang, we have Tarim River Basin. And the Heihe River Basin is the second largest inland river basin in China. The total area is more than 1,300 square kilometers. And here in mountainous region, we have a lot of glacier, we have permafrost, but they are in degradation. And downstream, they are extremely arid regions. Precipitation is very low. And in the last few decades, compared to many inland river basins in Central Asia countries, we also see a severe ecological deterioration in this region. For example, here, if we look into this remote sensing image, we can see a few decades ago, there is a big lake in downstream. But step by step, because of development, agriculture development in upstream, this terminal lake disappeared in 1919s. And here is the image of the year of 2000. So thunderstorms just prevailed in this region. This river basin is also used as an experimental river basin to do both fundamental study of hydrology of ecosystem and the integrated study of water ecosystem economy. In the last few decades, many research work has been carried out here. Here is just a review paper of this kind of research. So, based on many of the fundamental research in this river basin, we also, just 10 years ago, National Science Foundation of China kicked off a so-called integrated research on the eco-hydrological process in this river basin. One of the aims is try to provide fundamental theory and technical support for water security, ecological security, and sustainable development in inland river basins. You can see our idea is here. We need to develop reachful information in terms of observation system to support this kind of work. We also need to develop the integrated hydrology ecosystem and economic model to support all this kind of decision making. After many years of efforts, actually, currently we have integrated comprehensive observing system consists of, for example, more than 10 eddy current systems in different landscapes, wireless sensor network to measure soil moisture, soil temperature, leaf area index, and frequently, we also do airborne missions to collect various data, light data, microwave data, and optical remote sense data. Here is just an example of our snow observatory in the upstream of Heihe River Basin. So Professor John Palmer was here a few years ago. You can see we have different sensors to measure the property of snow, and we can compare this information with remote sensing products. And we also try to integrate various kinds of data. For example, based on many profiles of soil management, we can develop very high resolution, 100 meter the hydraulic parameters, soil texture maps. We can produce very high resolution evapotranspiration remote sensing products daily, 30 meters by merging different kinds of remote sensing. We also have 1 to 3 kilometer forcing data in terms of radiation, precipitation, and also air temperature. And we also make this kind of data available online, so scientists and policymakers can download data for their use. And the model integration is very important. My colleagues in the South University of Science and Technology, led by Professor Chun Miao-jin, they developed an integrated surface water, groundwater model. And all this kind of frozen soil, snow, glacier process has been integrated into this model. Oh, no, this is a model developed by my colleague, led by Chun Miao-jin. It's integrated groundwater surface water model with coupling of, for example, weight growth, mass growth model, and other ecological components. Here is a distributed hydrologic model to has cross-spherical components in terms of frozen soil, snow, and permafrost. And other colleagues in the Institute of Geography, they also developed some kind of water economic system model to investigate the interactions. And step by step, we try to bi-directionally link this kind of nature system model and the economic system model. We have some so-called interface model, land use model, and water resource model. We have this kind of bi-directional coupling variables to try to investigate the co-evolution between the nature and the human systems. And based on this model, based on various kind of data, we also developed River Basin Sustainability Decision Support System. And the indicators of this system is just we adopt the UN SDGs, SDG for sustainable water resource, SDG for ecological system, as SDG for society economical development, but we do some localization, we do some customization, and we can do future projection according to different scenarios of land change, of climate change. My colleagues also frequently provide policy suggestions to regional and central government. For example, in the last 20 years, we provide policy suggestions for rescuing the downstream oases and terminal lakes. We propose to pursue some economic development pathway for the whole river basin. And we are thinking virtual water as a new approach for water security for the whole Northwest China. We also try to propose some happiness-oriented water resource management in this river basin. I cannot say all these policy suggestions works, but partially they help to change the mind of the policy makers. And many ecological restoration policies has been implemented in this river basin. For example, the ecological water diversion project, means more environment flow for these lakes, has been implemented. You can see this drying up terminal lake actually has much restored, and the ecological restoration project have also been implemented in other endorheic river basins in Northwest China. So a few slides to show how the Water's great contribution to Asia G-WADI are on the agenda. Soon later, we'll give a good overview of this kind of work. Here is just a few slides. So G-WADI is a UNESCO HP project. We also have regional network we call the Asian G-WADI. We have some member countries. We have some pilot basins. How the Water very actively organized and he gave us a lot of supervision guidance on this regional work. For example, in 2007 in my city, he organized the second G-WADI Asia workshop and also G-WADI groundwater modeling workshop, because groundwater modeling is very, very important for arid region. Here is our opening ceremony. And here we have the group photo with the statue, Mother Yellow River. And here is some photographs in the field. You can see in our closing ceremony, Howard was going to address the audience. He's looking all this kind of liquor, wine, and Chinese baijiu. And he also organized other events in other Asian countries. For example, here are just a few photographs to show our events in Jordan 2009. And also a workshop on enhancing water and sustainable development in our region took place 2 years ago in Beijing. Howard is here, and Shus is here, and we also have some very nice time. Professor Yao is the chair of the Third Pole Environment Program. And he also edited 2 books on hydrological modeling and groundwater modeling, and some special issue in cold and arid region publications. I would like to mention in the last more than 10 years, I learned a lot from Howard. He's a founder member of G-WADI. He's also leading the GWAX. He's the co-chair of GWAX. I'm a SSG member. I learned a lot from Howard. So with this picture, with these beers, here I want to say, thank you very much, Howard.
Okay, so do we have any questions for Professor Li? Oh, Howard does. Something about beer, maybe? I'm not sure.
So we had a lot of discussion about the need to move science into policy, and you presented some good news stories. So what's the Chinese solution to managing the trade-offs and restoring dried up ecosystems?
Okay, what's the Chinese policy? I think the environment policy is getting more favorite for restoration of the environment, both environment in the ecological fragile region in West China and also ecological system in the east part of China. It's more favorable. In one word, it's more favorable for the ecosystem. Yeah, it's a hard question. I think many policymakers, as you know, actually they have background in science. They are scientists themselves, and maybe this way helps the policymakers to make good choice to make.
That's a very difficult question. Okay, thank you very much.